Okay, in the earlier video, we have derived first half of the bending equation. Once again, the beam is under pure bending. So if we now look at the stresses, let's take a cross section. Let's say the cross section is rectangular and our neutral layer or neutral surface is over here. So if we take a small element, after bending there is compressive stress here and tensile stress here. That's what we had discussed earlier. So now if there is compressive stress, if you draw the free body diagram of this part alone, so you have stress acting in tensile stress, pulling it outwards over here. So there is compressive stress over here, there is tensile stress over there. So now if you look at the cross section, which is rectangular and planar, you have force acting into the plane in this layer or in this small area, and then you have force acting out of the plane in this below the neutral axis. So now there is a force acting on this small elemental area. Let's say the area is dA and the distance of this small element is mentioned before. dF is now y e by r, which is sigma from here, from this relationship, times dA. This is the force acting on this small elemental area. So if this is the force on this area, which is at a distance of y from the neutral axis, the moment about the neutral axis. So now this is the neutral axis. This is the force dF that we computed, right? This force is acting compressive, right? So now the moment of this force on this small elemental area over there about the neutral axis, moment of force about neutral axis is dF times y, because this force is acting at a distance of y. So dm is f times y. So this is e by r y square dA. So now if you integrate the area, let's write once again, E is e by r y square dA. So for the entire cross section, this goes cross section. If you integrate, you get the moment M, which is acting on the member integral over square dA, which is acting on E by R integral over square dA. M equals E by R times the moment of inertia about the neutral axis, right? So this force will be highest at the topmost layer and 0 at the neutral layer, because y is 0 at the neutral layer, and once again it is highest tensile at the bottommost as you go towards the neutral axis. So now you have your M by I equals E by R equals sigma by y. This is your